All right, we're going to look at graphing right here an arc cosine function, but really this method can work for any of the inverse sine, inverse cosine, inverse tangent functions. The first thing we need to remember is because cosine is not one-to-one, the inverse of cosine is not going to be a function. So we have restricted the domain when we look at our inverse cosine function. So remember the restricted domain for cosine was 0 to pi. Okay, remember restricted domain for sine would be negative pi over 2 to pi over 2. Same thing for tangents, negative pi over 2 to pi over 2. So the domain of cosine is the range of inverse cosine. Remember what an inverse is? It's switching the domain and range. So that means the the cosine's restricted domain is going to be the range of our arc cosine. When I'm evaluating a t-chart for my arc cosine, I know that this domain for my cosine is now my range for my arc cosine. So I'm going to fill that in. 0, I'm just going to decide to count by pi over 4s. You could be more specific. You could add some pi over 3s or pi over 6s, whatever you want to do there. You could add some more values, but just for the sake of what's going on, I'm going to speed things up. So you get the idea. You get the idea here. So the cosine restricted domain was 0 to pi, so that would be the range of arc cosine, right? Because we've switched the domain and the range. Okay. So we are looking at y equals arc cosine of 2x. Well, if I take the cosine of both sides, that would mean that cosine of y is equal to 2x. Because cosine and arc cosine undo each other. But that would mean I'm taking the cosine of y on the other side. If I divide both sides by 2, that would mean 1/2 cosine of y equals x. So essentially, I've got x solved for and I've got y in my problem. Well, I have all these values I need to know the x value for. So I'm going to place these values for y in for y, see what I get out for x. Well, cosine of 0. We know cosine of 0. Cosine of 0 is 1. 1 times 1/2 gives us 1/2. Pi over 4, cosine of pi over 4 is root 2 over 2 times 1/2. That's now root 2 over 4. Cosine of pi over 2 is 0. 0 times 1/2 is still 0. Cosine of 3 pi over 4 is a negative root 2 over 2 times 1/2 is a negative root 2 over 4. And cosine of pi is negative 1 times 1/2 is a negative 1/2. Now I need to graph this, but first let's just reflect on what we've done. I remembered my cosine's restricted domain, and because I'm finding the inverse of cosine, the domain is now the range. I solved that equation I was given at the beginning. I solved it for x so I could plug in values for y and get out values for x. And that's where I'm at now. So let's plot these and kind of create some intervals that we can work with here. Our y values are from 0 to pi. So we've got 0. I'm going to let this be pi over 4, pi over 2, 3 pi over 4, and there will be pi up there. If I just go ahead and let 1, 2, 3, 4, 5, 6, 7, 8, if we say this is 1 unit out, then that should give us plenty of room to graph this. So when our x value is a half, our output's 0. When our x value is root 2 over 4, let's get that as a decimal. Root 2 over 4, we have a point, about 0.35. So this is 5. Be about here. 0.35, our output is pi over 4. At 0, we're at pi over 2. At negative root 2 over 4, we're at 3 pi over 4. And at we're negative a half, we're at pi. Now, one interesting thing that we need to remember, our restricted domain is closed. It's not continuing past 0 and pi. That means that our range is not continuing past 0 or pi. That is a definite ending. So we do not want to continue this with arrows. Those are endpoints to our curve. A little unusual for us, but our domain and range are finite.